All right, it's time to solve. It's time to do what? To solve. So please don't forget, I said Monday, Tuesday, Wednesday, I'll be taking different courses so I can be recording different chapters for the different. Let's be making progress. So any day you come, just choose one day of the week and come. Maybe you are free multiple days. Since I've now changed to different courses, you can now come. Maybe you used to be free 2 days a week. Those 2 days come, you will learn two different things. You used to be free 2 days a week, but because we're doing the same thing, you just chose one day and we are coming. You used to be free like 2 days sometimes in a week, sometimes 3 days. Those that are lucky. And anatomy is not even free at all. But others, microbiology, used to have like 2 days you are free. AEB, you can be coming, I'll be teaching different things. Now, since I'm recording different, I want to be recording different videos. So the idea again is I'll record all our classes from chapter 1 to the end. I will do a video of all our classes, physics, chemistry, math 101, math 102, FSB, from chapter 1 to the end. It'll be chapter by chapter by. So I'll do chapter 1 and finish it and label it chapter 1. Remember that they did the video for me, we did it. You see, type chapter 1, math 101. The title of the course, everything by success, then the class will start like that. Chapter 2, math 101, the title, relation and function by success, like that. To be uploaded one after the other for our students to learn. To be uploaded one after the. So all our registered members, all success registered members, message me if you're watching this video. Message me so that you've registered fully for our class. Message me so you have access to all these videos. So the money you pay for therapy will not just go to waste. It's possible that some of you are working, you can't come to class every day. Some of you are busy with other things, but you already paid for the class and you want to access what you paid for. The videos will be sent to you. Just send me your Gmail and it will be sent to you. Now, if you've not paid and you're watching this video and you want to register with us and you've not had time to come for our classes, you've been wanting to attend our class, but time has not allowed you. With this online idea now, you can also join our class and register, knowing fully well that everything you are supposed to learn with us, you can still learn it at the comfort of your home with your phone. That's the idea we're bringing up for all 100 level students. So you just message me. My number is on the channel. They message me and let us register you and send you videos for all your courses, chapter 1 to the end. All the things you don't understand in the lecture, we're going to break it down for you chapter by chapter so you can understand. So send us a message and let's work together. So let's continue the class now. A has been given already. I've dictated question A. Question A said, we are given this chemical equation, this reaction stoichiometry. We are given this chemical equation F2O3 plus 3CO to give 2Fe plus 3CO2. Fe2O3 plus 3CO to give 2Fe plus 3CO2. And the first question says we should find the mass of Fe. Fe is ion. So class, we need this part of the equation. Fe, find the mass of Fe. That will be produced from 10 grams of iron 3 oxide. Class, this iron 3. So these are the two people that are needed for the first part of the question. Find the mass of Fe, which is iron. That will be produced from 10 grams of iron 3. Class, this is mass to mass, right? But we'll now ask ourselves, from the balanced chemical equation, what mass of iron 3 oxide gave what mass of Fe? From the balanced chemical equation, what mass of iron 3 oxide gave what mass of Fe? From the balanced chemical. Let us find the mass of iron 3 oxide. Who has done that for so coming fast? Who has done that? Fe is 55.9. Use the one they gave you. But we have Fe2, that's 55.9 multiplied by 2. 55.9 multiplied by 2 gives us what? You see? 111.8, right? Plus, see, oxygen is what? 16. 16 times 3. So 111.8 plus 48. 159.8 gram of iron 3. So from the balanced chemical equation, 159.8 gram of iron 3 oxide gave what mass of iron? Iron is just 2 here, right? 2 times 55.9. Iron is 55. So 2 Fe means 2 times 55.9 is 111.8 gram of iron. This is from the balanced equation from the balanced equation. Did we confirm the equation is balanced? I think it's balanced, right? Fe2, 2Fe, O3 plus another 3O is 6O. O3 plus 3 is 6. On this side, 3 times 2, 6. Everybody's balanced. 3 carbon, 3. Because when you want to solve reactions involving chemical equations, first confirm that the equation is balanced. Having confirmed that the equation is balanced, we say 159.8 gram of iron 3 oxide gave 111.8 gram of iron. Now, what is the question I'll say? What mass of iron will be gotten from 10 gram, right? So 10 gram of this same guy, we give what? X. We don't. What do we do next? Cross. So we say 159.8 times X will give us what? 159.8X, right? We cross multiply. 159.8 times X gives us 159.8X equals 10 times 111 point. 10 times 111 point. So we have 159.8X equals to 10 times 111.8. 118. 1118 gram. 1118. Can we make X out of formula? Divide both sides by 159 point. 11118 divided by 159.8. 6.996 grams. So it means that you produce 6.996 grams of iron. 10 grams of iron 3 oxide. 10 grams of iron 3 oxide will produce 6.9996 grams of iron. Class, the B part of the question now. No. No. You can just say 6.996. It's a subjective exam. Put 6.996 gram. If it's an OBJ, then maybe if you don't see 6.996, maybe they are putting to 7 gram. But your chemistry exam is expected to be subjective based on recent years they have set. They've been they have been what? Subjective. Now, class, let's forge ahead. Let's not attempt the B part of the question, the B part of the B part of the question says, what volume of carbon monoxide at STP will be needed to convert 200 grams of iron 3 oxide to iron? What volume of carbon monoxide at ST class will be needed to convert what? 200 grams. So this volume to mass. Volume to mass. What volume converts 200 grams? What volume converts gram? Volume to gram means volume to mass to kill. What volume of carbon monoxide at STP? Class, there's an hint in the question. They say 1 mole of a gas at STP. 1 mole at STP is 22.4 liters of gas. Class, that's true. In chemistry, 1 mole of a gas, any gas at STP, contains 22.4 liters of that gas, or 22.4 dm cube of that gas. It contains 22.4 liters or 22.4 dm cube of the gas. 1 mole of any gas. Now, class, what volume of carbon monoxide? So in this time around, we are still using this chemical reaction, but let's pick out the people that are involved. In question A, when we're solving question A, the two people involved were this and this, right? But question B now, what volume of carbon monoxide? This carbon mono. Let's underline the two people involved. We needed to convert 200 grams of iron 3 oxide. This is iron 3. So it's between this and this. So clearly, in this reaction, carbon monoxide was used to convert iron 3 oxide to just iron. So it means that the job of carbon monoxide is to convert iron 3 oxide to what? Iron. As a matter of fact, is to cause the reduction of iron 3 oxide. If you look at this reaction, iron 3 oxide has been reduced to just iron. What's reduction? Removal of hydroxy. Anything that causes the removal of oxygen from a substance as was what a reducing agent, a reducing. So in this reaction, we can clearly say that what? The carbon monoxide is the reducing agent, we're reducing, and iron 3 oxide is the oxidizing agent. Because if you see, carbon monoxide has gained oxygen. From 3CO to 3CO2, even has more oxygen here. He has gained. Why iron 3 oxide has lost oxygen? Follow me, please. What volume of carbon monoxide at STP will be needed to convert 200 grams of iron 3 oxide? As usual, we'll go to the balanced chemical equation first. As usual, we'll go to the balanced chemical equation. From the balanced chemical equation, we'll interpret the same question from the balanced chemical equation. What volume of carbon monoxide converted what mass of iron 3 oxide from the balanced equation? Class, we have 3 moles of carbon monoxide. And from the what we're given, 1 mole of any gas is 22.4 liters. So if 1 mole is 22.4 liters, 3 moles will be 3 times 22 point. Class, follow me. If 1 mole of a gas at STP, and we have told this STP, is 22.4 liters. From the balance equation, how many moles of carbon monoxide do we have? 3. 3. So 3 moles of carbon monoxide will contain how many liters? X. Let's call it X, right? 1 mole is 22.4. Look at how we got that here. Class, this only works for gas. So don't go and say, so why did we do it for this one? This is not a gas. This is not a. It only works for gas. There's only 2 gases in this reaction. Carbon monoxide and carbon dioxide. But we're not doing it for carbon dioxide because it doesn't involve in the question they're asking us. Remember, we've underlined these two. These 2 guys are involved in the question, right? 1 mole of any gas contains 22.4 liters. 3 moles of carbon monoxide is in the balanced chemical reaction. We contain X, we don't know. Cross 1 times X, X. Got 3 times 22.67.2, right? So class, on the balanced equation, 67.2 liters of carbon monoxide converted what mass of iron 3 oxide? Let's find. What mass of iron 3 oxide was converted by 77.2 liters of carbon monoxide? What mass of iron 3 oxide was converted by what? 67.2 liters of carbon mono. What mass of iron 3 oxide was converted by 67.2 liters of carbon monoxide? Because class, go back to the question in case you are lost. What volume of carbon monoxide will be needed to convert 200 grams? Will be needed to convert 200 grams of iron 3 oxide to iron. But we now go to the balance equation. We find out that what volume of carbon monoxide you have here? 7.2 liters. Converted what mass of iron 3? Let's find the mass of iron 3. Who has done that already? We did it in the previous one. 159.8, right? We've gone the mass of iron 3 oxide in former A part. 159 point. Just to remind you, iron is 59.5.9 times 2, right? 16 times 3. We did it. We got 159 points. So from the balanced chemical equation, class, let's do it here. This CO and this iron 3 oxide. 67.2 liters of CO converted what? 159.8 grams of iron 3. Now let's go back to the question. This is from the balanced equation, right? To the question, what volume of carbon monoxide? X, we don't know. What volume of carbon, we don't. We now convert, what mass of iron 3 oxide now? We convert 200 grams of iron 3 oxide. Yes, 7.2 liters. That L is liters. 67.2 liters. What did it look like? Oh, yeah. Slide liters in full, so you'll be happy. Liters L. Liters, or you use DM, or you use DM cube. I had shifted your matric, right? To 18th. It was supposed to be next week Tuesday. You now move it to 18th. Thank God. No, we have class on your matric day, right? Don't worry, you be your matric gown. Be in class. Just do small matric, come and learn small. Go back and do small matric, come and learn. I'm joking. There won't be class that day. Enjoy. It's one day. Enjoy your. It was supposed to fall on a Tuesday, 11th. It's still falling on Tuesday to 7. 18th is also Tuesday. They just moved it 1 week. So I mean, so from next week, they start asking to come and collect your matric gown. I think you pay like 1K or 1.5. Have you said, after that, you said already? They've told you already. On Monday. It's not, we know everything. Come and collect your matric. I think they will refund you back that money if you return the matric gown. I think so. That's what they did last year. It's refundable. Why they are collecting that money? So you will not run away with the gown. Some people like gowns so much. You understand? So, someone say, wait, I want to carry their gown. Do Abby? So students run away with our gown. I don't know where they're going to start renting it out to other. I don't know. So they will collect like 1,500 or 2,000. Then when you return the gown, they'll give you half of the money back or something like that. I don't know. I'm trying to remember. But even to collect gown, you see queue. If you see queue for gown, everything about this place is just stress. Imagine a whole or year one, only 2 people will be giving the whole year one gown. Both science, arts, commercial, everybody. People will now be queuing. If you see long queue, the frame someone will meet at the arena. Long queue like this. Another stress, just to queue. Some people used to abandon that. I know they don't want to chop them. I know some people that say, I beg, for just matric, I beg. But just people want, if they want to snap, they collect their friend and just quickly snap. Take. Don't stress me, I beg. I will queue for test, queue for this, queue for this. Practical, I will suffer. I'll see queue for my own matric again. Everything is just stress. I don't know why why don't you just bring enough people to share to everybody? Or give the cost share. Cost share is go to the department. Everything must go through stress in this school. Why? Practical chemistry, you climb the last floor to go and suffer. Everything is stress. Physical clearance, did you not kill? Medicals, did you not kill? Why do you want to kill the people? I came to study, not to come and die. Everything is stress. Everything what? Exam to stress. Textbook stress. Assignment stress. Lecture, all is filled up, stress. Let us cross. 159.8 times x is 159.8 equals 7.2 times 200. We'll now divide both sides by 159 point. So 7.2 times 200 times 159.8. Someone should do the math for us. 13,000. 13,400 and after doing everything and dividing. After dividing, what do you have? 84 point. 84.1 liters. 84.1, that must be the volume of carbon monoxide that is needed to convert 200 grams of iron 3 oxide. That must be the volume of what? Carbon monoxide that is needed to convert 200 grams of iron 3 oxide. Please give me 2 markers. 2 markers, eh? Say it's 500. Take. I'll just buy one. I'll manage one. Take, come. This 2. This is under 500. Buy 2. Class, the question has a C part, right? The C part said, what volume of carbon monoxide will be needed at STP if 200 grams of iron 3 oxide was actually 90% pure? What volume of carbon monoxide will be needed at STP? What volume of carbon monoxide will be needed at if 200 grams of iron 3 oxide was actually 90% pure? Class, similar question, just that we're not going to use 200 here. We're going to use 90% of 200. Now, not the complete 200 is pure. Only 90% is. So B and C are very similar questions. Just that in B, the whole 200 grams of iron 3 oxide is considered. In C, only 90% of the 200 is considered is pure. It means out of the complete 200, only 90% is actually iron 3 oxide. So what is 90% of 200 grams? 180 grams, right? So it's just like cleaning here and putting 180. Are you there? So 7.2 liter of carbon monoxide gave 159.8 grams of iron 3 oxide. How many liters will give 180 grams? How many liters will give what? Class, are we following? How many liters will give 180 cross? How did we get 180? In case someone was writing, he didn't listen up. How did we get 180? 90% of 200 grams. For the C part, also asking for the same question. What volume of carbon monoxide? What volume of CO? Same volume, right? will be needed at STP if 200 grams of iron 3 oxide was actually 90%. So we're going to find 90% of 200 grams. We're going to find what? 90%, 90 over 100 times 2. If you do the math, you're going to have 180 grams. So class, the question, this C part of the question is telling us, what if it's only 180 grams of iron 3 oxide that is available? What volume of carbon monoxide will be needed to convert it? So still the same thing. If it's 7.2 liters, converted 159.8 grams of this, how many liters of this will convert 180 grams of? Are we together, class? We'll then cross 159.8 times x, 159.8x equals 7.2 times 1. Can we make S out of formula? Divide both sides by 159.8. We're going to ask 7.2 times 180 divided by 159.8. It's 7.2. After doing everything, 75.69 liters. 75.69 is the volume of carbon monoxide that is what needed. Class, write down mole concept. Mole concept. Mole concept. Thank you. Mole concepts. Mole concepts. Monday I will do physics. Tuesday I will do math 120. But today before I go, I will do that math 120 assignment and go. Then during the week I'll do a comprehensive video on math 120. Wednesday I'll come and do math 110. Thursday I will do chemistry. I'll do more on chemistry Thursday. Friday I'll do under math again. Saturday I'll do chemistry and math again. We're doing lots of videos. So class, chapter by chapter, chapter by chapter. Now, mole is the amount of matter that contains as many objects. Mole is the amount of matter that contains as many objects as the number of atoms in exactly 12 grams of carbon-12. I'll come again. Mole is the amount of matter that contains as many objects. Mole is the amount of matter that contains as many objects as the number of atoms in exactly 12 grams of carbon-12. In exactly 12 grams of carbon-12. Mole is the amount of matter that contains as many objects as the number of atoms in exactly 12 grams of carbon-12. In exactly 12 grams of carbon-12. This number is called the Avogadro's constant. This number is called the Avogadro's constant. This number is called the Avogadro's constant. It has a symbol of N subscript A. It has a symbol of N subscript A. It has a symbol of N subscript A. It has a symbol of N subscript what? A. It has a symbol of what? And has a value of 6.02 times 10 raised to power 23. Class, N subscript means N A. N what? Class, number of atoms. Na means number of what? Atoms. 6.02 times 10 raised to power 23 atoms. Or Avogadro's number. Or Avogadro's number. So continue writing. Therefore, mole is the fundamental unit in chemistry for measuring amount of substance or number of particles. Mole is the fundamental unit in chemistry for measuring the amount of substance or number of particles. Mole is the fundamental unit in chemistry. Mole is the fundamental unit in chemistry for measuring amount of substance or number of particles. Mole is the fundamental unit in chemistry for measuring amount of substance or number of particles. Open bracket. After particles, open bracket. Atoms, ions, molecules. Atoms, ions, molecules. Atoms, ions, molecules. Close the brackets. Let's write down relationship between mole and mass. Relationship between mole and mass. The following formula is used to calculate for mole when mass is known and vice versa. Right, and the following formula is used to calculate for moles when mass is known and vice versa. The formula is used to calculate for mole when mass is known and vice versa. Write a relationship between mole and Avogadro's number. Relationship between mole and Avogadro's number. Relationship between mole and Avogadro's number. Relationship between moles and Avogadro's number. Relationship between mole and Avogadro's. 1 mole of any substance is equal to 6.0223 times 10 raised to the power 23 atoms or particles or molecules or ions. 1 mole of any substance, 1 mole of any substance is equal to 6.0223 times 10 raised to the power 23 atoms, particles, molecules, ions. 1 mole of any substance is equal to 6.0223 times 10 raised to the power 23 atoms, particles, molecules, ions. Class, but you know that 1 mole of any substance is also equal to the molar mass of that substance. Do you agree? It's also equal to the molar mass of that substance. Now, what do I mean? If we say 1 mole of